All right, so let's do a quick refresher. So, what do you remember from last time?
I do remember that we what was it was a formula that we used to like create a shape on the other side.
Okay,
I'll be honest, I haven't been able to practice much throughout the weeks, so
all good?
I just need to refresh myself a little bit. But that's what I do
Yeah,
remember.
yeah. Okay, I'm going to remember the images. Yeah, that part's fun. Okay, so let's do a quick refresher. Um, okay, do you remember adding two numbers?
Yeah, yeah, I
Okay,
do.
let's do that real quick.
Uh, what was the code again?
So yeah, if like you were to use this as a calculator, like how would you add two numbers?
Yeah, okay. That it was just that, wasn't it?
Yeah. Okay, now let's
Okay.
run.
Yeah, okay.
Cool.
Okay.
Okay. Can we add and subtract numbers on the same line?
Mm, yeah, but you have to use PEMDAS.
Ah, okay. Could you show me?
Yeah. I forget how to. I think it's mistaken. Okay, no, I messed it up.
Okay, but you have the right idea.
What was it? In the parentheses, I think. Let's try that. No. Okay.
Okay, so what is it subtracting?
Yeah, you can't subtract 23 from 2 plus 2. Let's try one. I was not paying attention. And
Oh,
there's
but
still space
subtraction,
between the
you need,
parentheses. Sorry.
yeah, you need two things, right? Like the subtraction should be between two things. Right now,
Mm-hmm.
like the left of the subtraction is empty. Ah, okay.
And now that doesn't work because obviously that's not, you know,
Ah, okay. Should a two be there? The one your cursor's on?
the two right here, this two?
Yeah.
No.
Should so yeah. Yeah, let's try that.
Don't mind
Aha.
me. I'm a little rusty today. Don't
Yeah,
mind
that's
me.
all good. So the idea here is that on each side of the operator, so the minus or the plus, that's
Hmm.
like something, right? That's a number.
Hmm.
So the minus sign has a two on the left, the one on the right.
Yeah.
The plus sign has a two on the left, and it has like the whole thing on the right. You see that? The two
Right.
minus one?
Hmm.
Okay. So a bit of terminology. So the parenthesized two minus one, we call that an expression.
Yeah.
An expression is like you're expressing something to the programming language.
Hmm.
Something about expressions are that they have answers. So two minus one, they have an answer. It's one.
Right.
Okay. We call that
Okay.
answer a value.
Uh-huh.
In fact, the whole thing, the whole line two plus two minus one, that whole thing is an expression. You're
Right.
expressing this idea to the programming language, and it's calculating an answer for you, which in this case is three,
Okay.
right?
Yeah.
Yeah. So yeah, the key idea here is that operators need expressions on either side. Yeah. Okay, cool. So these are numbers. We could do arithmetic with numbers. We also
Hmm.
did algebra with numbers. Do you remember
Oh
what
yeah.
that meant?
We were coming up with values for X.
Okay, could you show me?
Let me just think. Okay. I think I don't remember the command that used the F or the function, but I do remember
Mhm.
it was like X equals 4, and then we did another line and it was like X plus 2
Okay. And how do we get six?
because the value for X is 4, so 4 plus 2 is 6.
Ah, okay. So variable substitution, right? We said x
Hmm.
is four, and when we get to line three, what is x? X is four. So four plus two is six.
Yeah,
Cool. Okay. So
exactly.
x is also an expression because x has an answer. The answer of x is four, right?
Hmm.
Great, cool, cool. Can
Yes.
let's just practice. Can we add more variables and do more stuff with variables?
Sure. what are you thinking? Like
Oh,
adding x to something else or making
sure.
another variable? Okay.
Yeah, let's do both. Let's make another variable and let's add
Okay.
x to the new variable.
Okay.
Cool.
There you go.
Hmm. Let's try something. On line 4, can we like add x to the right hand side? Can we do like 12 plus x, y equals 12 plus x? Would that work?
Sure.
Like before we run this, like will
Maybe.
this work?
It'll just yeah.
Is the math correct? It's 12 plus 14, 14 times. Wait,
Uh-oh.
like 16 times 4, 60. Oh yeah, yeah, sorry, so my math. Okay. Just practice. I was just making sure I was
Okay.
giving the right answer. Okay. You can't beat a computer. Okay. Great. So these, yeah, we have variables, which is an idea of algebra. Okay, do you remember?
hmm
Okay, I don't know if you remember this. Let's just delete everything. Can we write
Okay.
num dash min
Um,
and then min, min? Oh, did it freeze? Oh, there we go. Yeah, let's do opening
all right.
parentheses. And let's do one number, comma, another number. You can pick any number. Okay. Do you remember what this does?
It finds the smaller number, I'm pretty sure, I
Yeah,
think.
okay, let's run it. There is a minor problem with this though, but if you run it, it'll tell you.
Yeah. Functions must not have a space between expression and argument. Oh, this right here.
Yeah. So yeah, nummin is a function, right?
Yeah.
And what is the function?
The function is to find the minimum number.
And there are other
And the
functions as
minimum
well.
numbers. Oh,
Um, do
1 and
all
4.
functions give minimum numbers?
Not unless you ask it.
So yeah, what is a function like broadly speaking? Like not this function specifically, but all functions. What do they have in common?
They're supposed to do something. They're functioning.
Yeah, they do something, right? A key idea of functions is
hmm
that they take in stuff. So in this case, they take in 1 and 4. They do some
hmm
things, and then they give you back something else. So this function takes in 1 and 4 and gives you back 1. It takes in two
hmm
numbers and gives you back the smallest number, right?
Right.
It's
Yeah.
this idea of give and take. You give it something and you take something back, right?
Okay. Yeah.
Uh, so there are actually many functions. So for example, you can change num min. Can you change it to max? Change the min to max,
Yeah.
max. And what do you think that will do?
Yep. It'll choose the 4, the maximum number.
Maximum, yeah. So there are many functions. Yeah, there's so many functions we can't just use operators. We have to use functions because they have names. We can have a lot of names and we can do many things. In fact, we can do an infinite number of things. We can even make our own functions. You did mention that you remember the f, right? You remember that exercise we did last time with the f? Do you remember how to define a
Yeah.
function?
I don't remember how to do it, but I do remember that we did it.
Okay, so let's clear the screen again. Let's delete everything. So the very first thing to do to define a function, you must write fun because it's fun and it's also short for function. So notice how it's
hmm
bolded. So we're telling the
Yes.
programming language we are now defining a function. Okay. A function needs three things. Do you remember what those three things are?
Mm, no, I don't.
Okay, let's think about nummin.
hmm
What are the three things that nummin has?
It has the functioning part which tells you what to do, and then it has the variables that you give it.
Okay, not more broadly, it's not just variables, right? We passed in numbers just now. Uh,
hmm
it inputs, right? It takes in inputs. So it needs one of the
Yeah.
things it needs is our inputs. That's one thing of a function. What else does numbin
Mhm.
have?
Um, what else it has? Well, I mean, there's there's rules it has to follow. It tells the output
Hmm.
what it needs to give you. I mean, I don't know. Sorry.
Yeah, yeah. No, no, I understand perfectly. Yeah, the functioning part is to produce the output, right? You need something to produce the output.
Uh-huh.
So that, okay, that's the second thing. So we have inputs, and we need something that
Uh-huh.
produces the output. Okay, there's one more thing that numbing has.
Um,
When I say numbin, how do you know
mhm.
what it does? Which function I'm
It
referring
chooses the
to?
minimum number because that's what it that's what it's called. That's the name of it.
That's what it's
Num
called. The
min.
name. The name is important. If numbin
Hmm.
doesn't have a name, you can't even call it, right?
Yeah.
It's like if there's a guy in the street and you want to call that guy, like you can't do it if you don't know the guy's name. Well, okay, let's say
Mm-mm.
there's more than one guy in the street. That's like maybe like 500 guys, right? Yeah,
You want to
so
point out that specific guy, so you use his name.
exactly, yeah. So a function needs three things. It needs a name so that you can call it. It needs inputs so that it can take
Hmm.
in stuff. And it needs the functioning part that produces the output so that the function can give back stuff, right?
Right.
So three things. Okay, let's go do these three things. So the first thing we write after the file, let's add a space here. So
I'm
let's add a
sorry.
space. Let's add a space here. So find space, and then
Okay.
let's write the name of this function. What do you want to call this function?
Dog. I don't know.
Sure.
Off
Yeah,
the
you
top
can
of
call
my
it
head.
anything you want. Yeah, so let's do dog. Okay, what does this function take in?
Mm, man, I'm drawing a blanks. Okay. Um, how about, well, are we looking for a numerical value or like,
Sure. Let's say it takes in a number. So for inputs, we need to give the input a name.
hmm
So what do you want to call the input?
let's call it, I do a space on another line, or am I putting it in parentheses? Like,
Ah, okay. Yeah, so you're putting in parentheses. That's a good question. Nice.
and then the input name.
Yeah,
Okay. And then
cat.
a number.
Perfect. No. So over here inside of parentheses, we just put in words. We put in names because we need to name our inputs
Okay.
and nothing more than that. So yeah, I think that's pretty good. And then next you write a colon. So the third
Colon.
thing of the function is the functioning part, right? How it produces the output. We call this the body. And the
Uh-huh.
colon marks the beginning of the body. All right.
Okay.
For brevity, so just to make things look neat, let's add a new line here. Okay, so we have cat. And you say cat is a number.
Mhm.
What do you want? What do we want to do with this number? What do you want this function to produce?
Um, it could produce, how about the sum of three numbers? I don't know.
Sure. Okay, so what are these three numbers?
We'll do, should I just, in parentheses, outside of parentheses?
So just right here on line three, it doesn't have to be in parentheses.
Okay. 13 times 2 plus 4.
Okay, can we use cat somehow? So cat is the input, right? Can we do something with cat?
What do you want to do with it?
Can we replace one of these numbers with cat?
Okay.
Cool. All right, so this is the body. So we need to mark the end of the body. To do that, let's hit new line and write END. Great. Okay, notice how it's all highlighted now. We have just defined a function. Let's run it.
All right. Oh,
Ah,
I
okay.
keep forgetting not to put a space between, yeah, okay.
Cool, cool.
Parentheses. So we'll do, oops. on. Oh, it moved the. Okay, well, must have white space to separate. Okay.
Ah, remember these operators, they need expressions on both sides of them, right? So we have two on the right, but what should go left of this
Okay.
star?
Left of the star should probably be, I don't know, maybe a plus. Will
Well,
that
it
work?
needs a
Let's
number,
see.
right? To multiply two numbers,
A
you need
number. Oh, yeah. Oh, yeah, you need another number. I will do that then.
sure, okay. But now we have 13 hanging on its own. Oh, and that too.
Yeah. So then we just have to. Okay, hold on. This is a lot of. Okay. Will that run? Oh,
Oh,
okay.
okay.
So what's the problem with this now?
Okay, so let's simplify things a little bit. So notice how like the on
Yeah.
line three, if we look at the one, what's to the right of the one?
hmm The right of the one, the parenthesis.
So and the whole parentheses, right, like three times two. The thing about this is
hmm
that you can't just have like so these are expressions, right? One is an expression, three times two is an expression.
Yeah.
You need to
hmm
have operators between them. They can't just be standing next to each other.
Okay.
So let's simplify things. Why don't we delete 13 minus 1? Let's just have fewer things on our screen here. And then can we delete the two as
Yeah.
well? Let's delete the second two, the two after the parentheses. Yeah, that
Okay.
one. Okay, let's run this. Ah, nothing happened.
They don't know what
So
cat
what?
is.
Ah, so we didn't use the function, right? We defined it, but we didn't use it.
Yeah.
Okay, so but we have called function. We have used functions before, right? Like how we used nummin just now. Let's do that again. How do
hmm
we use the function dog?
Like what variable it's under or
Okay, so create a new line here, and
under here or
oh, after line
between.
four.
Okay.
Yeah. And so to call a function, to use a function, first you must refer to it by its name. So let's write dog. Okay. And just like like when we use nummin, how do we use nummin?
Well, we put parentheses behind it and
Ah, okay, so let's put parentheses. And
gave it
what
numbers.
and numbers, okay, let's give it a number.
10.
Perfect. Let's run it now.
Okay.
Excellent. So how do we get 16?
Because dog is the function for cat. So if dog is 10, then cat is 10, and 3 times 2 is 6, plus 10, which is 16.
Nice. Awesome. So yeah, this is algebra with a computer.
Yep.
So the nice thing about this is that you have like you can think of this as like a really advanced calculator where you can like make your own
hmm
functions, you can do stuff with them, you can call it whatever you want. All right, sweet. So let's keep practicing with this. I'm gonna annotate on your screen. Let's see if it works. Can you see? I drew the word hello on your screen. Can you see it?
Yes, I do.
Okay, perfect. All right, I'm gonna give you some challenges to practice what you've learned so far. So, let's- so I'm gonna start with this. Define a function that
Find a
doubles the given
function.
number. Uh,
Okay. Function that doubles the given number.
so let's wait. Let's not delete it. Let's keep that just for your
Ooh,
reference. Yeah,
okay.
yeah, for your reference. Let's keep that. And yeah, let's define a new function. You can just create a new line there.
That doubles a given number. Okay.
Yeah. So what's a good name for this function?
I'll do dub for double.
Sure. Yeah. Sounds good. What's a good name for
That's
the
fine.
input?
Um, hmm. Let's say T.
Okay. So let's try to give our names like something descriptive so that when we
Something
read a
more.
name, we know.
Okay.
Yeah.
Okay. Well then, if that function is up, then the input should be. I don't know. What do you think? I'm
So a given
drawing
number.
blanks.
So what's a good name for number?
Well, other than num,
Oh,
I feel like
let's
that,
let's
but
do it.
isn't
Let's
that
put
already
num.
a function name, even if it's already
Yeah.
a name of another function? Okay.
Well, num itself isn't a name for a function, right? It's just NUN num, right? It's not
Okay.
nummin. It's not nummax. Yeah.
Okay.
All
And
right.
then the
So
function
what
that
do we do
double.
here? So what's the functioning part of
Well,
this
first we have
function?
is
Hmm.
to double a given number.
Okay. How do we do that? How do we double a number?
Well, when I think of doubling, I think of times two.
Cool. Okay. Let's do that.
Shouldn't we define what num is first? Give num a variable like we did for dog.
Well, if you look at line two and three, like cat is
Mm-hmm.
perfectly defined, right? On line two, that's where cat is defined.
Okay.
So likewise on line six, when we say num is inside the parentheses of dub, we're saying num is the input to dub. So in that sense, num is
Okay.
defined there. Yeah, cool. Nice.
Should we run that? Or end.
Okay.
Whoops.
Okay, very good. Okay. Yeah, all right, let's run it.
Well, that's still from from dog.
Okay. So how do we check that dub is correct? That is actually how do we use dub?
Well, again, we have no we don't know what num is.
So like how do we use dog just now?
We added a 10. So I'll do oops, typos. Can I run it?
Yeah, let's do it. Very nice. Yeah, so we call this calling a function. In mathematics, we would say applying a function, but in programming, we would say we call a function. It's like you just ring up dub, like, hey, dub, take this five. It gives you back a 10. Nice. Okay. Now on to our next problem. Let me clear this one.
Do
So what's that?
I said I think the connection dropped a minute.
Oh yeah. Seems to
Can
be
you
phasing
repeat
in
that?
and
I'm
out.
sorry.
Oh yeah,
Yeah.
I was just saying that I'm gonna give you your next problem now. Okay,
Oh, okay.
fine.
Hello.
Yep. Um,
Oh, there it is. Okay.
there we go. Yeah,
Sorry, it
so I was
wasn't
just
there.
drawing out. Okay, so I'm gonna
Find the
draw
volume.
more stuff with
Sorry.
this.
Okay.
Let's say you're given like one of the sides here, S. Can you get the volume of this cube?
Hmm. Is there a formula for volume?
Okay, fine, I'll give it to you. Yeah,
I'm sorry, I haven't done this in such a long time. I'm
it's
rusty.
okay. It's like getting the area of a square, but you multiply it by one more S.
Oh, okay. Okay.
Yeah.
Okay. Find the volume of a cube given the length of one of its sides. So what's the length of this side then?
So that's the input to your function,
Okay.
right? That's why it says given, right? Whenever you see given, it means that's going to be the input to your function.
Okay.
Yeah.
I'm thinking for a minute.
Hmm.
Thinking. Does that look about right?
There's only one way to find out.
Okay. Well, we haven't defined what the side is, so.
We haven't called it, right? We haven't called volume. Yeah, let's call it.
Mhm. So what is it?
Um, you can decide. Any number will do.
Okay.
Ideally, a small number so that you know the answer is correct when you see it.
Okay.
Okay.
Oh yeah, that wasn't a.
Looks about right. Yeah, awesome.
Yeah.
Okay. Hmm. Um, okay, I'm going to give you this next problem. Are you familiar with Pythagoras' theorem? Hello?
I'm right here.
Uh, yeah, are you familiar with Pythagoras' theorem?
Pythagorean theorem.
Yeah.
Oof, that's a throwback. Y equals mx plus. Is that okay? Am I right? Y equals mx plus b.
That's the equation to the linear. That's the linear equation. So yeah,
Okay.
I'll
See
give
ya.
you a briefing. So this is going to be important for your next problem. Oh,
Okay.
that's a terrible line. Let me erase that.
It's okay. I can't see it anyway.
Okay, yeah, I deleted it before you could see anything. Okay, let's say you have like a triangle that's like standing upright like this.
Oh, I remember. I remember.
Oh, okay.
A,
What is
a
Pythagorean
square
theorem?
plus b square equals c square.
Yeah,
Okay.
yeah.
Yep.
Okay, let's say you have so C is always the side that's slanting, that's on a diagonal.
Mhm.
A and B are the sides that are like flat on the ground or like standing tall, right?
Mhm.
So the C squared equals A squared plus B squared, right?
Mhm.
Yeah. So when I say we're doing algebra, we're literally doing algebra right now. Okay.
If I knew all of that, I would have came prepared.
It's okay. All right, but I mean, we're not all going to be doing this all the time. We will be moving on to like other stuff that's not algebra. When
Okay.
we move away from numbers, which we will soon. Okay. All right. So I'm gonna give you a problem now.
Okay.
Define a function that uh computes c squared given a and b. Call this square distance. Okay. I've just written it. It should show up your screen any moment now.
Yeah, I can see it.
Yeah.
Okay. Find a function that computes c squared given a and b. Call this square distance. Okay.
So what should be the name of this function?
Well, I called it SQU, the
Okay, so
square, and S for distance.
okay, for the purpose of this problem, I'd like you to name this function square distance, like two words separated by a dash. It will be important in a
Okay,
moment.
so
Yeah.
I didn't know how long you were supposed to make the names. I've just been
Oh, they could be as
keeping
long
it
as you want.
simple.
But yeah, like ideally like
Okay.
not like 500 characters, right? But yeah. But yeah, square distance is fine. Okay, and what should it take in?
Okay.
What is this given?
Um, well, if it's supposed to compute c squared, it should probably be a square plus b square, right?
Okay.
So I'll do can I do like a single letter just to
Yeah,
keep it
yeah.
concise or
Oh yeah.
okay, I do.
Okay, so in parentheses, when you're defining the inputs, you can't have math. Like you can only give like one
Okay.
names. Yeah.
Okay.
So yeah, the math has to go into
Okay.
the body.
Right. All right. So I'll just can I just do F here then?
Okay, but how many inputs does this function have?
Well, if it's probably two or
Two, right? So we need a
these
second
two.
thing. So it's comma
Yeah.
separated. So to add a second thing, just add a comma and then a new name. Okay, F and G. All right. For
Hmm.
your benefit, I recommend naming them A and B, just so we can
Okay.
directly use the formula that's drawn on the screen. Yeah.
That makes sense.
Yeah. Okay, so yeah, what do we do with A and B?
Square them.
Okay, cool.
So
Okay, how do we square a number?
square it is times two, right? Or at least that's
Ah,
what I
that's
remember.
that's double. You're thinking of double.
Darn. Okay.
Yeah.
So
So like a
can't even
square,
drive
like how
myself.
what is the area of a square? How do we calculate the
Area of
area
a
of a
square.
square?
Area of a square. Um.
Yes. Let's see. Let's draw a square. Okay, pretend that's like a perfect square. Let's say I know like one side's x.
Uh-huh.
Oh,
Well, that's all the sides multiplied by each other. It's
all
all
the
four
sides
of them.
multiplied by each other. Yeah. So how many sides are there?
Mhm.
Oh, my choice. Oh, out of connection again.
Hello.
Oh yes, yeah, the connection got cut off. Oh, my beautiful
Sorry.
drawing. Yeah, all the sides multiplied by each other, right? That's the last thing I heard from you. So
Yeah,
how?
so it'd probably be A times A and then B times.
Yeah. Okay, I don't even need my drawing anymore. Yeah, you got it.
Yeah. I'm
That-
sorry. I have not b done school in such a long time. I am
It's all
extremely
good.
rusty on my math.
All good. All good. Perfect. No, that's perfect. Yeah. Nice.
So then we'll
Okay.
do square distance. No, how about I'll do two again.
Okay.
Uh,
Oh, sorry. Let me clear that for you so you can read the text.
yeah.
There we go. There we go. You can read it now.
When argument was passed to the operator evaluated the function defined to accept two parameters. Oh yeah, I have to define both of them. I forget.
Yeah. So a
So
little
what
bit
I
of
should.
terminology. So like
Hmm.
every time you're calling the function, you're passing in actual numbers, right?
Yeah.
We call these arguments. They are arguments.
Okay.
Um, like A and B on line 14, like
Hmm.
the names for inputs, we call these parameters.
Okay.
Yeah, so parameters are placeholders for values. Arguments are actually the values.
Okay.
Yeah, okay, yeah.
Okay. So maybe I'll do two and one. Let's see.
Nice.
Five. Because two times two is
Cool.
four, and one times one is one. Wait.
Cool,
Yep.
cool,
Okay.
cool. Okay. All right, so this session's gonna expire because I didn't pay for the Zoom subscription.
Okay.
So I'm gonna close this one out and send you a new link on Gmail, okay?
All right.
All right, I'll see you in a minute.
Okay.
Okay, excellent stuff. All right, so this is gonna be my last math bit,
Okay.
I think. So yeah, do you know the saying, I think, therefore I am?
Yes.
So this guy, he's a philosopher, but he's also a mathematician. And so is Descartes,
Hmm.
this philosopher mathematician guy. they created something called a Cartesian plane.
Okay.
Okay, have you seen this?
Um, yeah, like latitude, longitude, like it looks like a graph, like
Yeah, exactly. It's a
quadrants.
graph. Yeah, it's a 2D graph. So so at the center, at the cross, we that's the origin.
Okay.
That's 0, 0, right?
Mm-hmm. Yes.
So given this, right, we can specify the position on this graph using two numbers. So for example, let's say at this point, let's say we are, let me add some ticks here. So let's say each tick is one.
Okay.
So we have three on X and we have, let's say, two on Y. Let's say I want to specify this position here.
Mm-hmm.
You see the dot.
Yes.
So yeah, I'm drawing this with a mouse, so it's very sloppy.
That's
Uh,
okay.
so we can specify where on the graph we are using
Yes.
coordinates. That's two ordinates.
Mm-hmm.
That's like so like first we write where on X are we on, so we're on X equals 3. Where on Y are we on? We're on Y equals 2, so that's 3, 2. You see that?
Mm-hmm. Yes.
So so we call this a the Cartesian plane. It's a plane is another word for 2D space. So given any
Yes.
2D space, we can say where we are,
Mm-hmm.
uh, relative to some origin. Okay. Oh yeah, so this thing right here, we
Okay.
call this the origin.
Yep.
More sloppy writing. Okay. So what's really interesting is we can get the distance from any point to any other point, including we
Mm-hmm.
can get the distance between a point to the origin.
Okay.
And how will we calculate the this like distance to origin, that slanted line right there? How will we do that?
Calculate the distance from the origin.
Yeah, like between 3, 2 and the origin, how do we get that distance?
Um, well, I suppose you would subtract it from the origin coordinates.
How do we subtract from the origin coordinates?
You take um e- or the origin's x minus, our x over here, which is 3,
Okay.
and then you minus for y, which is 0 minus 2.
So if we did that, we got two numbers, right? We got 3 and 2,
Mm-hmm.
right? But we need one number, which is the distance.
The distance
The
between them both.
Yeah.
Hmm.
Okay, let me give you a hint. Might
Okay.
surprise you. What's a good color? I think a color that contrasts. So let's say ice blue. Huh, this thing
Okay.
over here. Actually, you know what? Let me not use my mouse for this. Let me use an actual line.
There
So
you
this thing
go.
right over here, does that does this look familiar?
Yeah, it's
Have you,
Pythagorean theorem.
it's my oh crap, Pythagorean theorem. Okay. Okay, how do we use this?
It's the same as our square distance formula.
Oh, okay. All right. Okay. So I'm gonna give you your next task now.
Mm-hmm.
Define uh distance to origin. Sorry, let me pull it.
That's okay.
Okay, I'm pulling. All right. It's coming in a moment. Okay, this one's a bit of a mouthful,
Okay.
but I promise you, it's actually very simple.
Define a function that consumes two numbers, x and y, and that computes the distance of points x, y to the origin. Yeah, that is mouthy. Okay,
Yeah.
let's see. It'll kind of, trying to figure out what way it would make sense to write this.
Yeah.
Mm, like I understand what I'm supposed to be doing here. I'm just like I'm stumped at word how to format this, if that makes any
Hmm.
sense.
Yeah, so the first step is to give it a name. So let's start with the name.
Yeah,
What's a
that's
good name
true.
for this?
Um, we'll do origin. I don't
Okay.
know because we're working with origin. So,
Okay.
and we're doing two numbers, x and y.
Okay.
So x, y. I feel like it needs more than that because it's not just x and y that we're doing. We're trying to find the distance.
The distance, but is the distance an input or is it the output?
The distance is the output. You're
It's the
right.
output,
Okay.
right? So it doesn't come in here. Yeah. So X and Y is perfect.
Mm-hmm.
Okay. X and Y. What do we do with X and Y?
Um, well, if we're trying to find the distance, are we just gonna do y times y and x times x, I think.
Yeah, but do we have something that does that already?
Yeah, we have square distance, so we really don't need
Oh,
this.
nice. Could we use that?
Mhm. So we'll do, I don't want to say, well, okay, I guess that does work. We'll just have to define where we'll have to call out what square distance is this time around, I guess.
But when you use a function, you gotta like give it stuff, right? Because function taken things.
Yeah,
So should square distance taken stuff?
should I do square distance minus origin?
So let's start by calling the function. So square distance, it takes in stuff. What should square
Yes,
distance take?
should take x and y.
X and Y. Okay, how do we do that?
We'll have to, shouldn't we end this function and then call square distance, which is, oh,
Oh,
wait. Or can we do that? Can we do that within this function or do we have to end it out?
so okay, you must end the function, but you can call a function inside the body of a function.
Yeah, okay.
Yeah.
So I'll actually change the numbers up here. Can
Oh,
I? Will that make
you
any
could, but
sense
that's not
or
going to help you, right? You could
okay.
change it, but the reason why that's not going to help you is because that is outside the function definition. So those
Yeah.
two are like completely separate. But line 19 is actually correct. You have the right idea here.
I'll just leave it this way.
Yep, but you must call it. So you gotta do
Okay.
opening parentheses and then put in the things on line 19.
Okay.
That's before the closing parentheses. So
Okay.
right immediately after the E, yeah.
So I'll do x and just x comma y.
Yeah, but you gotta surround X comma Y in parentheses.
Yeah.
Yeah. Before the X as well.
Oh, I have to
Yeah, so what
separate
this
them
is
both.
saying
Okay.
is, oh, X and Y should go into square distance.
Okay.
But let's remove the parentheses after the E. Yeah, so that's
Okay.
perfect.
So just okay, I that looks kind of it looked weird to me at first, so I wasn't
Okay.
sure if that was right.
Oh no, yeah, it's right. Yeah.
Okay.
So yeah, now we can end it. Oh, so
So there's a space, I think, maybe.
and that so line 19, that opening parentheses at the beginning doesn't have a closing parentheses to match it, right? Because parentheses come in
Oh,
pairs.
double parentheses. See, yeah,
Yes.
that
Yeah.
that always gets me a little bit.
Oh yeah, it's kind of tough sometimes. Okay.
hmm
I believe if you run this now, it will tell you you're missing one thing.
Yeah, highlighted
Okay.
text. You should maybe add or remove some text to fix your program. Look carefully between the highlighted text that they're missing colon. Oh, yeah, I completely, that was oversight
Yeah.
on my half. Wasn't
Okay.
paying attention. Hmm. Well, I mean, it is kind of a function call.
So what does it say about the function call?
Functions must not have space between the function expression and the argument. So this here,
Hmm.
there we go. And
Okay.
doesn't give us anything.
Okay. So there's actually one thing we need to do. Line 19,
hmm
we got the square distance. We got C squared, but we're looking for C, right?
Yeah.
So yeah, let me draw this out. So sorry. So we have c squared, a squared plus b squared.
Mm-hmm.
So, but we have this. Oh my Lord, my drawing. Okay, this is like barely legible, but I hope you can understand what's happening.
C squared equals A squared plus
Plus
B
b
squared.
squared, right? But we're looking
Yeah.
for c. How do we get c?
I mean, I would assume we'd have to do the opposite of what we did here to
We have
get
to sort
to,
of
yeah.
we could unsquare the c squared, right?
Uh-huh.
How do we unsquare? Like, what's the math term for unsquaring something?
The math term for unsquaring something. I don't think I've heard of that. I don't think I've
Okay,
heard of the term for it before.
okay, it's actually not called unsquare, it's called square root.
Okay. Oh, all right. See, yeah. Square
So
root. I know
remember?
what a square root is.
Okay. So a rule of algebra, when you do an operation on one side, you must apply the same operation on the other to keep things balanced. So
Yeah.
if we want to apply a square root to c squared, we also must apply a square root to a squared plus b squared, and we
Mm-hmm.
arrive to c equals a squared plus b squared, right? So here's the beautiful thing. We have c squared. Oh, oh crap. Oh, hello?
Yep, I'm right here.
Oh yeah, I think I got lost for a second. Okay, there we go. Yeah. So so this is actually the distance formula, c equals square root of a squared plus b squared. But the
Mm-hmm.
beautiful thing is we already have c squared, right? So we don't even need to think that hard. So let
Yeah.
me I'm gonna actually erase all this. It actually boils down to a very simple idea. You know what? I'm gonna even erase that too. I think I accidentally erased the prompt statement, but I don't need that
So if
anymore.
we're doing square root, it'd have to be the square root of 5, wouldn't it? Because that's what C square is.
For phi specifically, yeah. But in our
Oh, well,
case, c
yeah.
squared is our square distance, right? Square
Yeah,
distance xy. We sort of need to wrap it in a square root. How do we square root something in Python?
good question.
That's a very
Um,
good question because
yeah.
unless you are a magician, you're probably not gonna know it.
No.
Yeah. So when you're learning a language, chances like a real life language, a normal one,
Hmm.
not pirate, you probably need a dictionary with you. When you see a word you don't understand, you can refer to a dictionary, right?
Hmm.
So when you're learning a programming language, it's much the same. You also need a dictionary.
Yeah.
So I'm gonna hand you the dictionary for numbers in this language. So like things like num_min and num_max, like where do they come from? You can
Hmm.
find out from the dictionary. I've just sent in Zoom chat if you wanna pull that up.
Oh, yeah, I think you sent this to me last time.
Oh,
Oh,
really? Okay,
there
I'm
it is.
gonna
I didn't.
clear the screen because it's blocking you.
Okay.
My beautiful drawings. All right, so the trick here is what you can do is you can do Control F and just type in root, ROOT. There we go.
Oh, they have a command for it already.
Yeah, a function, right? Yeah.
Okay.
So how do we use this? So firstly, what's the name of this function and how many things does it take in?
Number square root, and it takes in one
Perfect.
variable.
Takes in one number. Okay, so how do we use this in our code to solve our problem?
Hold on, I don't know how to hide this at the top. Okay. Um, we'll have to do the number square root, but
So where do we
numbers are
use
three
that?
and two. Sorry.
So where do we use num square root?
I suppose, well, do we use it with our function that we just created, the
Yeah,
origin?
yeah. So what are we square rooting exactly?
We're square rooting c squared, but we don't have
C
c squared
squared.
right now.
Oh, technically line 19 is your c squared.
Okay.
Square distance, right? So that's our c
Yeah.
squared. How do we square root that? How do we square root line 19?
Well, maybe I can just do this origin.
Ah, okay.
Spelled it wrong. Do you think that would work?
Well, origin is a function. We can run it. It will tell you something.
Okay. It's first argumentative evaluated to an unexpected value. Let's use a number.
So, but origin itself is just a function, right? We need to call the function, right?
Yeah, we haven't called it yet.
Yeah, so what you can write origin. So if you write origin num square root, but then you got to do opening parentheses and pass in numbers. So after the end,
Hmm.
so on line 21, after the final
Okay.
end, you can do opening parentheses. Oh, sorry, but before the closing parentheses. So
Okay.
immediately after the end, yeah. So opening parentheses, and then now call it like normal. Like what are the two numbers you want to pass in?
I'll do I'll do 3 and 5 this time.
Perfect. Okay, and now, all right.
I have to put spaces between these. Hold on.
Okay. Okay. If you run it now, it will tell you something,
Okay.
but it tells you a very minor thing that's easily fixable.
Howard didn't expect your program to end as soon as it did. You must be Okay, it's again with these double parentheses.
Yeah.
Oh, that's a
Okay.
long number.
But let's say we want to get the origin of the distance to origin of another two numbers, like something other than 3, 5. How will we do it?
Wouldn't you just do the program again with different numbers?
Okay, could you show me?
Sure. Do
Cool. Hmm. It, it's kind of strange, right? Line 91, 21, and line 22, they
Mm-hmm.
repeat the num square root, right? See that?
Yeah, okay. What'd you
So
say?
whenever we, yeah, lines 21 and 22, whenever we want to get a distance to origin, we always have to wrap origin with num square root.
Mm-hmm.
Like, so if we do this like 50 times, we have to keep writing num square root 50 times, right?
Yeah, or else it wouldn't be able to work.
Is there an easier way to do this?
Um, I mean, probably just to do the number square root in general, maybe. I don't know, but
In
then that would kind of
general,
cut it.
yeah, how do we do it in general?
We'll just cut out the origin part.
Okay, so I haven't, that's actually the right idea, but you got it the other way around. You kind of want to
Okay.
just, so line 23, you kind of just want to write origin, right? So replace num
Okay.
square with origin, and the origin does the num square root for you, right? That would be
Okay.
really nice, right?
Yeah. Well, does it?
Well, but right now it's not. How do we get origin to do the num square root for you?
We'd have to change the function.
Okay, how do we change it?
Should we just make a new one or just edit it?
Oh, we can edit it.
Okay.
So where would we put num square root here? What are we square rooting?
X and Y.
Is it just x and y? Square distance?
Sorry, I think it went out again.
Oh, so yeah, sorry, what are we square rooting?
Are we square rooting square distance or X and Y?
Yeah, we're square rooting the entirety of line 19, right? Because that's c squared. That's square distance.
Mm-hmm.
So how do we num square root the entirety of line 19?
I want to say we just add it,
Okay, let's do it.
probably outside of the parentheses, though I'm presuming.
Okay. Yeah,
That'll
and
just, yeah,
lines 21 and 22 don't need the num square root anymore. Origin's already doing it.
there you go. So I
So
can
yeah,
just, I did it again. Sorry, just for
yeah,
practice sake.
yeah. Nice, yeah.
And it should do it. Okay.
Yeah. And lines 21 and 22, they could be deleted now. Because that's the long way of writing it, right? We have a better way of writing it now.
Yeah.
All right. All right. So this idea here, firstly, notice
Hmm.
how you can call functions inside functions.
Yes.
So, and then when you call functions, you can parse the argument could also be a function call.
Okay.
See that? So
Hmm.
we have, so there are two things here. First, when we call a function inside a function definition, that's like, that's like, it's like two notions of function composition. So in like algebra, we call this function compositions.
Okay.
I'll just type this out real quick. Just for your benefit. You don't have to memorize this stuff. So like I don't know, like in like this might be a eternity ago for you, but like have you seen like something like this
Okay.
in mathematics?
Yeah.
Or like have you seen something like this?
I've seen that before. Yeah. Something like it.
Yeah, so that's what we just did, right?
Yeah. Basically. Yeah.
Cool, yeah. Okay, good work. Okay, I recommend saving this. If you'd like to either like connect to Google Drive or literally copy the text and paste it into a Google Doc or to a text file on your computer, just for
Okay.
your future reference. Okay,
Yeah. That's a good
we are out of
idea.
time. Let's wrap up. Okay. So very good work today. We have covered a lot of ground. So how do you feel about this?
I feel good. I'm gonna probably need a little bit more practice. I mean, you have to watch this over, but I feel
Awesome,
pretty
yeah.
good.
Awesome. It is on YouTube. Your first session's also on YouTube. Um, okay, great. Okay, I hope you learned something today, and I hope to see you again.
Thanks.
Awesome. All right. Bye bye now.
Bye bye.